This chart is demonstrating how the geothermal heat pump operates in heating mode, and I'll show you how it can be reversed to operate in cooling mode. In heating mode, the compressor is obviously compressing the refrigerant and making it very, very, very hot. So it's coming off the compressor, quite a high temperature, in excess of 80 degrees Celsius. It's going through a reversing valve, which in heating mode is allowing the hot refrigerant to go to, in this case, a fan coil unit for heating air in a building, or in the case of producing potable water or water for hydronic floors or radiant wall panels or swimming pool heating, to go to a water-based heat exchanger to transfer that thermal energy into water. Once the refrigerant's gone through that heating process, it comes back through and will be condensed, comes back to the earth loops where it will be usually in a liquid format, and obviously we would like to use the ground to transfer energy into the refrigerant to heat it up so that it can be preheated to go into the compressor. In this system we're demonstrating that the liquid is coming through back to the earth loops at about 2 degrees Celsius, a little bit less than 2 degrees Celsius. The earth loops will actually allow the constant ground temperature of the earth to evaporate the refrigerant off into a vapour state. So a vapour comes back to the active charge control, which can go into the compressor and provide a very, very economic and efficient form of providing heating. In cooling mode, this valve simply reverses the flow of refrigerant. Rather than sending the hot refrigerant off to the air handling unit or to the water source, it actually sends the refrigerant down into the ground loops, where the ground is taking heat away from the refrigerant and allowing the refrigerant to be condensed. It will come back to the heat pump, or back to the fan coil unit through the heat pump to provide cold energy for air or water to be chilled. So in heating mode, the liquid side of the refrigeration cycle is coming down inside the liquid loop into the ground. So we've got refrigerant that is in a liquid state at perhaps minus 10 degrees Celsius, going down here in Victoria into 15 to 17 degree ground. That warm ground temperature is obviously going to be providing warmth into the refrigerant, warming it up and allowing it to evaporate off and come back up to the heat pump in a vapour state where it's compressed, made hot and used for air or water heating applications. Simply reverse cycling the system and putting the 80-85 degree refrigerant down into the ground, and now allowing the ground to draw that heat away from the refrigerant through the copper, through the grout into the ground, allows the refrigerant to be cooled and condensed and come back up the liquid line, forming condensate droplets. The condensate for the top 15 metres of a 30 metre loop has an insulated tubing on it that allows the ground portion of the system to bring liquid refrigerant back to the heat pump for cooling purposes. This insulation reduces the chance of flashing from the hot refrigerant coming down on the vapour side, and also stops the constant ground temperature's warmth from providing thermal energy back into that condensed refrigerant.